Okay, let's check what you got. So on number 3, the square root of c squared is c, and the square root of 36 is 6. So your answer should have been c plus 6, c minus 6. Number 4, the square root of k squared is k. The square root of 81 is 9. So our answer should be k plus 9, k minus 9. Okay. Number 5 is actually going to be prime. Okay, now see if anyone caught this. Why would this be prime? Okay, the reason why it's prime is this thing right here. Okay, the pattern we are working with is difference of squares. Now this is technically sum of squares because you're adding. So although m squared and 9 are both perfect squares, we cannot factor due to the addition or plus, or sorry, due to the plus sign. Okay, so although m squared and 9 are both perfect squares, we cannot factor due to the plus sign because it has to be difference of squares, not sum and not plus. Okay. All right, try number 6. (16x squared minus 9). Okay. Okay, same concept. Are they difference of squares? Is 16x squared a squared number? Yeah, can I take the square root of 16 and x squared? Yeah, the square root of 16 is 4, and the square root of x squared is x, so 4x times 4x, is that 16x squared? Yeah. And the square root of 9 is 3. So my answer would be 4x plus 3, 4x minus 3. Okay, so this one is just different because it had a coefficient in front of the variable, but it's still a squared number. So we just get a slightly more complicated answer. Okay. Number 7. So see how knowing our perfect squares helps a lot. Number 7, 36a squared minus 121. 36a squared minus 121. So square root of 36 and the square root of a squared would give us 6a, and the square root of 121 is 11. So my answer is 6a plus 11, 6a minus 11. Okay, now I'm going to write down one more problem for difference of squares, and then I'm going to do the mini review and see how you do. So number 8, 25z squared minus 64. Let's see what you do for number 8. Give you a second to try it. So square root of 25, square root of z squared, be 5z. Square root of 64 is 8. So 5z plus 8, 5z minus 8. And that's all that pattern is too, okay? Finding the square root of both terms and putting it in your pattern, okay? Only time that you can't do it is when it is a addition or plus symbol. Okay, and I'm gonna write down a few problems for you to practice as a little mini review from our other types of factoring, which was GCF, grouping, and trinomial. Oh, run down to the very last line. Okay, try these problems.